Hello friends, today I'm going to solve LeetCode problem number 733, float fill. In this problem we are given an m by n integer grid image where image ij represents a pixel value of the image, and we are given three integers SR, SC and color. SR represents the source row, SC represents the source column, and color is basically the pixel value of the image. Now we should perform a float fill on this image starting from the pixel value image SRSC. And to perform the float fill, we are going to fill all the four directionally connected pixels starting from the starting pixel which have the same color as well, right? So let's look at this example over here and let's try to see how we could solve this problem. So we are given a matrix n by n, and here our source row and source column is equals to 1, so our SR is equals to 1 and SC is also equals to 1, and now the color given to us is equals to 2. I'm just writing C for shortcut. So now what we need to do is we need to convert the pixel value of this source to 2, and also we need to change all the four directionally connected pixels which are of same value to this color as well. So what we do is, now we know the pixel value of this node, so we keep the pixel value of that node which is equals to 1, and then we update this value to 2. Now to the next four directions we are going to change the pixel value as well. So we start from one of the directions. We can either do BFS or DFS. Here I'm going to perform DFS. So we start from one of the directions. Let's check this direction, and then in this direction we see that the pixel value is equals to 1, which is equals to the previous pixel value. So what do? We convert this to 2, so we are changing it to 2 as well here. Next, for this also we are going to go in all the four different directions. So we just go to the upper direction, but we see that there is no such cell, so we try to go down. Now what do we happen to see here is, while we are going down, we have already converted this 1 to 2, right? So it will basically not match the value, the previous pixel value, because now it is equals to 2. We are only comparing this value to the current value. So since we are not able to go either top or bottom, now we try to go in this direction, and we found a 1 here. So 1 is equals to the previous pixel value, so we converted it to 2. And similarly for this also we go into all the four directions. We cannot go in this direction, so next in this direction we can go, and we see that it's equals to 1, so we convert it into 2. And then for this also we try to do the same thing. We came from the top, so basically we are not able to change this, so we go down and we are now able to change this one. And for this one we try to go to the other directions as well. So while we're going down, there is no cell here, there is no cell to the left as well, and towards the right the pixel value here is equals to 0, but our previous pixel value, that is the pixel value to be changed, is equals to 1, right? Because that was the pixel value of our source, so we won't be changing this one as well. So since now we have tried all the directions for this node, we revert back to its calling node, and for this one node also we check all the remaining directions, and we see that all the remaining directions are already changed and we cannot go to this direction, so we go back to its calling node. And similarly here also we go back to its calling node, and from this calling node we can go to the right, and we see that its value is equals to 1, so we convert it into 2. And then from here also we try to move to the different directions. We cannot move to the top, and to the bottom the value is equals to 0, so we don't change. To the right we have already made the change, and to the left we do not have a cell. So from here also we go back to its calling node. Now from this calling node, since we have been to all the directions, we go back to its calling node, and from this node we went to the top right. Now when we to its left also we have a different color node which is equals to 2. To its right also it's equals to 0. To its bottom also it's equals to 0. So basically we are done with all the color changes. So this will give us a result like this. So that is what we need to achieve. So we are gonna traverse all the 4 directions in and then while we are traversing we check the pixel value which should be equals to the previous pixel value, and also we should have a valid cell. So we are going to perform a DFS here. So now let's go into this function and perform our DFS. So basically we can perform a recursive call into this function instead of creating a DFS function here. So I'm gonna do that. So starting from our image, okay, let's first of all look at the constraints. The length mn, and the value is ranging from 1 to 50, and the value of the color can be from 0 to 2 power 6, and source row is 0 to m, and column is 0 to n. Okay, so that sounds good. Now what we do is we start by previous color. Okay, so we need to save the color as R and as C. Okay, now that we have the color, we are going to change the color of this image, right? So the color at this pixel will be equals to the color that we are given. And now we also need to go 4 different directions, right? So I'm just going to create an array of directions. So one, we will go towards the column 0 1 0 minus 1, and then along the row that would be 1 0 and minus 1 0. Okay, now that we have all the 4 directions, we are going to loop over each of the directions of dir, and let us create a new row. So that would be sr plus our direction at x-axis, and c equals to sc plus the change that we want to make, right? So this will give us the 4 directions, 4 different directions. And now we need also to check if the cell is valid or not, right? So if r is less than 0, then it's not valid, or if r is greater than equals to the length of the image, then also it's not valid, right? Similarly for C, the columns is less than 0, then it's not a valid column, and the value of column greater than equals to image of 0 length, that is the length of the maximum number of columns, then also it's not valid. So in this case we just continue okay, continue to another direction, else we know that's a valid cell. So now we check if the pixel value is the same as the previous pixel. So rc equals previous color. If that's the same, then we are going to change the pixel at that point, right? So for that we are going to perform float fill. So we will just recursively call the float fill function with the image, where this image is now changed at this pixel value, and now our new source row will be R, column will be C, and the color will be the same. And finally we are going to return our image. Now let's try to run our code and look at the solution. Okay, so we are having a problem here. What's the problem? Let's look at that. So we have our previous color set here, and then we have the color changed. Now we are creating an array of directions, and for each of the direction we are okay. So what the issue is that, what if the color is equals to 1, the color at the current index is equals to 1, and the color here given to us is also equals to 1. So if that's the same color, then we will be stuck in a loop, because we are now changing 1 to 1, and then we go into a different direction, and then from here also, while we are traversing across 4 different directions, we convert them into one, and then we again go back into a loop. So we need to check that. So if previous color is equals to the color, that is, if the color is itself the pixel already is colored with this color, then we don't actually need to color it at all, right? So in that case also, we are going to just return our image. Now let's try to run our code. Yeah, so it worked, right? Now let's submit this. Awesome. So talking about the time complexity, let's look at the time complexity. So what are we doing here is we are moving over each of the directions in a DFS way. So we want to be traversing all the nodes, but in the worst case, what if all of these nodes were equals to 1? In that case, we will be traversing each of the node once, right? So in that case, the time complexity becomes O of n. And talking about space complexity, we are not using any other data structure other than this array, which is also a fixed array size, right? So the space complexity would be constant, but when we are taking into consideration this recursive call, it will take some space in stack, right? So in that case, that would be O of n space complexity. So that's all about this solution. I hope you liked my solution. Let me know in the comments down below. Thank you so much.